Hey, advanced math students, trust each of you did well on the test that you took for me yesterday, and you're ready to start into some new material. Today in lesson 71, we're going to be talking about another shape that we have in math, and this shape is called the ellipse. Already this year, we've talked about circles and we've talked about parabolas. We saw how to take those different equations, put them in what was called standard format, and then either how to describe them with their vertex, the direction, or the center, and then also the radius. Well, we want to kind of do the same thing today as we're looking at our ellipse. We're going to look at what is the standard format of an ellipse, and we're going to see how can we correctly graph that on our Cartesian plane. Let's go and start our lesson this morning by looking at what is an ellipse, and then we'll walk through some different questions together about what does the standard format look like, and then we'll see some questions where we actually have to graph it together. For our purpose, I'm going to describe an ellipse as a flattened circle. Okay, so what does that mean? Another way that I can say this is an ellipse is going to look like an oval. I took my circle, which is normally perfectly round, and I flattened it. I squished it together at the top, so now it's a little bit longer than it would be going up and down. Or I took the circle on the side and I smushed it in. That way it's growing a little bit taller than it's going to be wide in our question. So again, another way that we can think of an ellipse is going to look like a circle in your question. Now, what we're going to notice about an ellipse, and this is where we're going to focus our time with regard to how to graph. An ellipse has two axes. Those two axes, one's going to go left and right, and one's going to go up and down to tell me how wide or how narrow a certain part of the ellipse is going to be in the question. The first axis that you have in an ellipse is called a major axis. And I think you can figure out even from the title, the major axis covers a majority of the ellipse, so that one's going to be the longer of the two axes in your question. I'll show you in a few minutes, based on the standard format, how you would know if that longer axis is going left and right, or if that longer axis is going up and down in your question. Now, with regard to the major axis, just to make note of this, that major axis could be horizontal from left to right, vertical up and down, or it could be inclined. It could be slanted. For our purpose, we're only going to deal with the first two, that the major axis is either horizontal or vertical, as those will be the easier of the kinds for us to work with when it comes to graphing with our ellipse. Well, if you have a major axis, then you're going to have a minor axis as well, and the minor axis is going to be the shorter of the two axes that you have. So it's the one that's a little bit more narrow, the one that you have it squished together in your question. All right, so let me go ahead and show you what is the standard format of the ellipse, and this is where we're going to get the information necessary to help us graph as we're approaching our questions at the end of today's lesson. There's two different formats I want to give you for the standard format for an ellipse, and we're just going to focus on the ones that are centered at the origin. So when it's centered at the origin, I don't have to worry about shifting to the left or to the right or up and down to begin with. We can just draw based on the information given to us. Now, you may be thinking, why are there two separate equations? Because it depends, is the ellipse stretched out along the x-axis, or is the ellipse stretched out along the y-axis? Let me go ahead and show you what these two equations look like, so make sure you jot these down in your notebook for me. Notice in the ellipse format, you have fractions, and in between those fractions are plus signs. The first equation, x squared over a squared, plus y squared over b squared, and it is equal to 1. So in the numerator, we're always going to have x squared and y squared. In the denominator, those aren't going to be letters. Those are actually where the numbers are going to be. And I'll explain in just a second as to where the numbers are at, depending on which one is going to be stretched out further, the x or the y axis. Notice the only difference for the second equation, the a and the b have switched around. So now it says x squared over b squared plus y squared over a squared is equal to 1. Again, the x squared and the y squared are always going to be in the numerator. There will be numbers in the denominator, and depending on the location of those numbers will help us determine which axis is the longer of the two axes in our question. Now, a very key thing when it comes to the standard format for the ellipse, notice what both of these equations are equal to. They have to be equal to 1. That's going to be vital to help us as we go to graph in our questions in a few minutes. The question must be equal to 1 before you can pick out the information about the axes with regard to which one is longer and which one's shorter in our question. The last example that we'll do together today, the equation does not equal 1, and I'll show you how you would correctly get it into that format so that way you can approach the question for how to pick out these numbers that you were going to need. Now, kind of talking about those letters A and B, how are we going to correctly use them when it comes to the question? The letter A is always associated with the major axis. Remember, the major axis was the longer of the two axes that you have. That means the letter B is going to be associated with the minor axis that you have in the question. We just mentioned a second ago, the only difference between those two equations was where the letter A and where the letter B was located. If you notice that the letter A is underneath the x squared, now it was like the first question that said x squared over a squared. If that letter A is underneath the x squared part of your fraction, the x-axis is going to be your major axis. Well, then the converse would have to be true. If the letter A is underneath the y squared, this was like the second equation I showed you, where it said y squared over a squared, then the y-axis is going to be the major axis. Okay, so what does that mean? If the bigger number, and that's what we're saying with A being the major axis, because major means it's the bigger of the two pieces, if the bigger number is underneath the x in your question, technically x squared, your ellipse is going to be stretched out going left and right. If the bigger of your two numbers that you see in the denominator is underneath the y part, underneath the y squared, then your ellipse is going to be stretched going up and down. Okay, so where the bigger number is located tells you which axis is the major axis in your question. Now, notice in those formulas, it says a squared. So like if there was a 25 down there and I had to pick out the letter A, well, what do I square to get to a 25? It's the number 5, and I'll show you how you would use that 5 on the Cartesian plane as you're picking out your question. Okay, so just a couple more notes here, then we'll get our two examples down. The letter A, remember it's always the bigger of the two axes, it's half of the length of that axis. Okay, so like if I said the major axis is the x because my bigger number is underneath the x squared. Once I locate the A, I would go right that many spaces and I would also go left that many spaces. So it's splitting it in half. So if the major axis, I saw that number was 25, well, what did I square for 25? The number 5. So I would go 5 to the right, and I would go 5 to the left. If I notice the bigger number is underneath the y squared, and let's say that bigger number was 36. What do I square to get to a 36? The number 6. Well, if that was underneath the y squared, I would go up 6 spaces on the y-axis. I would also go down 6 spaces on the y-axis because I'm going half the distance one way, the other half of the distance the other direction. Okay, so the same idea for B. B is half of the length of the minor axis. Just make sure that you're going both directions, to the right and to the left, or up and down when you go ahead and put your information on your problem. Okay, so I'm going to skip over the next couple things. I was going to mention them originally, but I don't think that's going to be necessary for us. I think once we actually get to see the questions, you'll understand what I'm referring to with these letters A and B. So I'm going to skip past a couple things real quickly. Don't worry about those. Let's go ahead and take a look at this first example together of x squared over 25 plus y squared over 9 is equal to 1. Now our job is to graph that ellipse. Is the question ready for me to graph? It is. The question's already in standard format because it equals 1. That's got to be the case before you graph. So how do I know which kind of ellipse do I have? Which kind of oval do I have? Is it stretched out going left and right, or is it stretched out going up and down? In order to make that decision, I need to find the bigger of my two numbers. Well, the two numbers that we have are 25 and 9. Which one of those two numbers is bigger? Hopefully, obviously we know the correct answer would be 25. The 25 is located underneath the x squared. So what does that tell me? The oval, our ellipse, is going to be stretched out along the x-axis. So I'm going to have a longer distance that way and then a shorter distance going up and down on the y-axis. How do I know how many spaces to move in each of those directions? In our formula, in the denominator, it says a squared and b squared. So let's take a look at this number 25. What can I square to get to a 25, the number 5? So on the x-axis for the vertices, the 4 points that I'm going to connect in just a second, I'm going to go right 5, so that was 5 comma 0, and I'm also going to go left 5, so negative 5 comma 0. What's going to happen on the y-axis? Underneath the y, I see 9. What do I square to get to the number 9? A 3. So on the y-axis, I would go up 3 spaces, and I would go down 3 spaces. Now, as I'm moving in each one of these directions, I'm always starting at the origin. So notice the second set of ordered pairs that I wrote down. I have 0 comma 3 because I started at the origin. I went straight up 3 spaces. Then I went back to the origin and I went down 3 spaces to get to 0 and negative 3. Okay, so again, how did we pick out that information just to make sure we're understanding? The question already equaled 1, so it was ready for me to pick out the information, the numbers that I needed. I looked at my numbers 25 and 9. The bigger of my two numbers was 25. That was underneath the x squared, so I know the x-axis is the major one. That's the one that would be the longer of the two axes in the question. How do I determine how many spaces I have to move? We're asking ourselves, what do I square to get to these numbers? What did we square to get to the 25? It was the number 5. So on the x-axis, I'm moving 5 in each direction. On the y-axis, underneath the y squared, we saw the number 9. What did we square to get to the number 9? 3. So on the y-axis, in both directions, we're going to move a value of 3. Okay, so let me show you what the picture looks like here. I got my Cartesian plane. You should have a sheet of graph paper in your work packet this week, and you can write this example down, and you have it for when you do your questions as well. Notice on the x-axis, the major axis, I went 5 spaces to the right, and I went 5 spaces to the left. That's the longer of the two axes that we had on this question. Same idea for the y. The number that was associated with the y was 3. So we went up 3 spaces, we went down 3 spaces, and then we were able to connect them, and that's what our ellipse looks like. It's a flattened circle, because I took the top of the circle and bottom and I smushed it in. Now it's stretched out further to the side, so it looks like our oval in the question. Let's finish up today by looking at a question that's not equal to 1. We'll see how do we put it in standard format first, and then we'll look at, to finish up, how do we correctly graph with the ellipse. Well, what was the key characteristic? If an ellipse was in standard format, it had to be equal to 1. Well, something else that standard format has that this question does not currently have are fractions. Remember, it said x squared over something plus y squared over something was equal to the number 1. Well, I don't have equal to 1, and I don't have fractions. How would I get those pieces into my question? I'm going to take the 15 that's on the right-hand side of the question, and I'm going to divide every single piece of my question by 15. Okay, so why does that make sense? Because 15 divided by 15 is 1. That would put 1 on the right-hand side of the question. And now notice on the left-hand side of the question, we have the fractions, which are necessary if you're going to have an ellipse in your problem. Now, how do I simplify? How do I get this into that standard format? You're just going to reduce with these fractions. So we take a look at 5 and 15. What can 5 and 15 both divide by? 5. So 5 divided by 5 would cancel that out, and 15 divided by 5 is 3. So the first part in our standard format is going to say x squared over 3. Now notice in the numerator, we only ever want it to say x squared or y squared. We don't want it to say 5x squared, or like we're going to see in a second with the 2y squared. We do not want any numbers in the numerator. We only want numbers in the denominator of our question. So if I move over here to fraction number 2, now fraction number 2 wouldn't reduce like I just did with fraction number 1, but I can't have this number 2 in the numerator because all I want it to say is y squared. So I need to still kind of reduce this fraction, but not using kind of the same thing I did on the first one with them both dividing by 5. So what I'm going to have to do is think, okay, I'm going to kind of work backwards here. So 15 divided by 2 is 7.5. So I'm going to cross off these two numbers. So it's kind of like I'm dividing them both by 2. So I can knock off the 2 from the numerator. 2 divided by 2 is 1. And 15 divided by 2 is 7.5. Okay, so again, I do not want any numbers in the numerator, so I'm going to have to divide them out to get it down to the denominator in our question, and now I have it in standard format. So x squared over 3 plus y squared over 7.5 is equal to 1. Now that the question is in standard format, we can pick out the two numbers that are necessary for how many spaces on the x-axis do we have to move, and how many spaces on the y-axis do we need to move. If you take a look at that equation, which one of the two axes is going to be the major axis? How do we make that decision? We found the one that was the bigger of the two numbers. Well, between 3 and 7.5, which one's bigger? 7.5. Where is that 7.5 located? It is underneath the letter y. That means this ellipse is going to be stretched out more, going tall top to bottom, and it's going to be smushed in on the sides of the question. Now, this one I can't just think through like I did in the last question with how many spaces to move, like the square root of 25 was 5, the square root of 9 is 3, so I'm going to have to use my calculator. So let me start in that y direction. What do I square to get to a 7.5? Well, I don't know. So I'm going to type in the square root of 7.5, and I'm going to have to move in the y direction 2.74 spaces. Okay, so that's what my calculator gave me for the square root of 7.5. I'm going to go up 2.74, and I'm going to go down 2.74. Notice the x's here are 0 because I'm not going to the left or to the right at all. The number that was associated with the x was the number 3. Well, what do I square to get a 3? Again, I don't know. So I'm going to put it on my calculator. The square root of 3 gave me 1.73. So in the x direction, we're going to move right 1.73 and left 1.73 on our question. If I put that information on our picture, this is what our ellipse now looks like. Notice the major axis is the y-axis. It's going taller than it is wide in our question. I went up, 2.74 spaces, and down 2.74 spaces. I went to the right 1.73 and left 1.73 spaces. And so as you're doing your questions tonight with regard to your homework, make sure your question equals 1. If it doesn't, then divide that number over so you can get those fractions and you'll have the question equal to 1. Find the denominator with the bigger number, that one's the major axis. To determine how many spaces that you have to move, you're square rooting. What number did I square to get to that number in the denominator of your question? Once you determine all your pieces, move left and right the same number of spaces, and also up and down the same number of spaces, and connect those 4 vertices to come up with your picture of the ellipse.